Next presentation, Dr. Ali EBRAHIMIAN from FIU is going to talk about the comprehensive decision support tool for accelerated bridge construction considering social equity. Dr. EBRAHIMIAN.
Good morning, everyone, and thank you for listening to my presentation. Today I'm going to be talking about a project that we recently started to work on, and that's about the development of a kind of comprehensive decision support tool for determining the suitability of accelerated bridge construction techniques in bridge construction projects. I have Dr. Islam Mantawi as a co-PI from Rowan University on the team, and also my PhD student Nassim Mohammadi Azhar, who is actually doing the specific tasks in this project. So, okay, so basically, state DOTs across the country use different approaches for decision-making about adopting ABC methods in bridge projects. And these approaches are ranging from complex to simpler approaches. So the most rigorous probably method is the software developed by FHWA based on the work previously done by Oregon DOT, and that's using the AHP method analytical hierarchy process. So in this method, there are many criteria, and what the method do, or the methodology in this software, is that the decision maker, whoever the decision maker is, they should go ahead and do pairwise comparisons between each of the two criteria that you see here. And in this way, they are actually determining the relative importance or weights of the criteria. And the next step, they will evaluate each of the bridge projects against each of these criteria to determine if they are suitable for ABC or not. And finally, they will determine, or the software determines based on the AHP method, a score for each project. So as you see,
Dr. EBRAHIMIAN, sorry, we are still seeing your the cover of the presentation.
Oh, okay.
The PowerPoint has not advanced.
What do you see now?
Right now, nothing. I think Ali is going to give you again the.
Okay. So yeah, I'm gonna. Okay.
So if you can just share again. Okay.
Sure. So what do you see now?
We are on second slide, right?
Okay. So do I need to switch?
Yes.
Okay.
Yes.
All right. What do you see now?
The second slide.
Okay, great. So yeah, and do you see the third slide?
Yes.
Okay,
yes,
awesome. So this is just a quick overview of the FHWA ABC software, which is based on the AHP method, and these are the different criteria, many criteria that you are seeing here. And as I explained, there should be a pairwise comparison of these, of each of these two criteria to determine their relative weights, and then evaluating each of the projects based on each of these criteria. And then based on the AHP method, a score will be developed for, it will be calculated basically for each project, and then the projects will be compared based on that score. So as you see, this is kind of time consuming, and a lot of state DOTs are looking for kind of simpler projects to be more practical in their applications. So on the other hand, you see that there are other methods, simpler methods that are being used by other state DOTs such as Utah or Iowa, Wisconsin, Minnesota. And those are in general basically using spreadsheet tools, and those are based on simple multi-criteria decision-making methods together with or complemented by some qualitative analysis using some flowcharts. So to give you some example, you see the Utah DOT method here. UDOT basically uses a two-step process. The first step is using a spreadsheet to use a simple multi-criteria method, which is based on the simple additive weighting or simply a weighted average method. And in this step, they calculate an ABC rating score based on 8 different factors or criteria, such as average annual daily traffic or delay or detour time in each project. And they finally calculate a final score between 0 to 100 for each project. 0 means absolutely no ABC, 100 means for sure go for ABC. And then in the second step, they go, depending on the final score of each project, they go to different routes through a flowchart that you see a screenshot here. And they, in this phase, they actually evaluate other or indirect benefits, such as environmental benefits of ABC. But one thing that should be noted here, that there are a lot of subjective components in both of these steps. And this is one thing that we're really hoping to be able to improve in our improved tool. So Wisconsin DOT kind of uses pretty much the same approach, of course, with different criteria and a different flowchart, but the general approach is the same as UDOT. Iowa DOT uses a 2 or basically 3-stage process. Well, in the first step, they use a similar tool such as UDOT, and they calculate a final score for each project. And then they basically eliminate or take out the projects where the score is less than 50. So these are the projects that are not good potentials for using ABC techniques. So in the second step, they only look at the projects with higher rating scores, or the rating scores equal or greater than 50. And then they go through a flow chart and they do more evaluations. And finally, they will select some projects that looks like good potentials for ABC methods, and then they use the FHWA AHP software tool to calculate a final score for each project. So Minnesota DOT or MnDOT uses a 3-stage process for determining about the suitability of ABC. In the first step, that's like an initial screening, and they use some criteria, and this is mostly quantitative analysis. And then they just pick the projects with a final score greater than 60, and then they do some qualitative evaluations. In the second step, the qualitative evaluation is being done by the district project manager only. And then there are some projects that will be selected through the second phase. And in the third phase, further evaluations will be done on the project, but this time by the district project manager together with the district bridge engineer and also traffic engineers and probably other related units. So as you see here, the complexity of the methods are different in different state DOTs. So Connecticut DOT is basically using a middle ground approach. So the method that is being done by the Connecticut DOT or City DOT is actually a 1-step method. So that's just a spreadsheet tool that uses the weighted averaging method. So in that case, it looks like simple, but it does consider a lot of important criteria. And that's why this is kind of a well-received method. And this project is basically about improving this method. We're trying to see how we can improve this method. So let's have a closer look at the details of this method. So first of all, this is a spreadsheet tool, and we are comparing 2 alternatives. One is ABC, the other one is no ABC, or conventional methods. The method uses 10 different criteria, as you see here. So the criteria that you see are, for example, average daily traffic, which is pretty much in all the methods. But this method does consider the cost of conventional versus ABC method, also the time saving or the user impact reduction from the ABC methods, together with other limitations or construction limitations from the work zone and things like that. So those are the criteria. And then the criteria are being evaluated based on a score of 0 to 5. That's mostly a qualitative evaluation that has to be done, although some of our input data are quantitative, such as the ADT, average daily traffic. Then we do consider weighting factors here to show the relative importance of each criterion here. These factors are predetermined. That means that we cannot change it through the process, and so those are there. And as you see here in this picture, the time saving through ABC and also cost analysis are those two factors with higher weights. They have each 30% weight here. And then finally, the method uses a weighted averaging algorithm and calculates a final score for each project. And then in the final decision-making step, if the final score is between 60 to 100, that means go for ABC, or at least consider it, seriously for your project. If your final score is smaller than 50, that means do not go for ABC. And the method is basically kind of vague when the final score is between 50 to 60. So it says further evaluations needed. So we have been thinking about the areas that we can improve this method. So the first thing that we were basically asked to do with the call for this project was to include additional criteria, including the safety of the work zone, or the potential or the benefits of ABC methods for reducing the risk of crashes in the work zone, and together probably with other criteria related to social equity and environmental justice that we can add here. Then the other thing is currently the method is using quantitative evaluations only, so we were thinking how we can consider more quantitative evaluation of criteria instead of qualitative. Then determination of weights. Again, these are predetermined weights. Even that means that these are not applied to other state DOTs. And the other thing is, even with the city DOT, if the decision makers change in that state, well, there's not a guarantee that the new administration, likes to use this set of weights for the projects. So we are thinking about, proposing a simple but systematic approach for determining the weights of criteria here. And finally, we want to add more clarifications about where the final score is between 50 to 60. So the criteria that we are thinking about adding here is first of all, is the work zone safety, or reducing the risk of crashes by using the accelerated bridge construction methods. And these are just some examples from Florida that shows clearly show the increasing trend of crashes per work zone, and the importance of this method to be considered, and this benefit of ABC to be considered in the method. And the other thing is the direct implications of ABC in social and environmental problems. So looking at social problems or social factors such as population density and crime rate, we can clearly see that if you're working in a, for example, high crime rate area or a highly populated urban area, you can expect to have some interruptions to the bridge construction that can cause a delay in the construction time. And by using ABC, we can reduce the chance of those interruptions. And more importantly, thinking about social equity, by using ABC, we can have more public consent due to the reduced project time, especially in urban areas, and in some cases, faster revitalization of, for example, low-income areas or high crime rate neighborhoods. Thinking about environmental factors, we can think about bad air quality in some areas, or extreme heat, which is a really high concern, at least in some areas of the country, including South Florida, where we live. And those environmental factors could be a threat to our workforce health, and they can basically increase the construction time. So by using ABC, we're expecting to reduce the workforce exposure to those environmental threats, and also in some cases providing accelerated environmental benefits for our urban communities. So in terms of adding risk of crashes and social equity to this method, we are basically using and leveraging the findings of the past ABC UTC projects and associated PhD research works that has been recently done at FIU. And to summarize, we have 4 specific research objectives in this project. So the first objective is to consider the benefits of ABC on work zone safety and incorporating risk of accidents as a new quantitative criterion in the tool. The second objective is to consider the benefits of ABC in terms of social and environmental factors or social equity. And by considering or by addressing these 2 objectives, we're basically providing a more comprehensive method, decision-making tool method. And the third objective is basically developing quantitative measures for the evaluation of decision criteria where possible. So in this way, we are making the Connecticut DOT method less subjective, which is good, which is something that we are always looking for in our analysis. And finally, the fourth objective is developing a systematic method for determining relative importance or weights of criteria. And by doing this, we are basically making the decision-making tool more flexible and making it applicable to other places. And finally, after developing the improved tool, we plan to demonstrate the application of the improved tool in a real case study. And this is probably my last slide here. So you see the flowchart of the different tasks in this project. We are done with task 1, which is a literature review, looking at other states to see how we can leverage what we have in different states. And then at this time, we are developing the methods or indexes for road safety criteria, social equity, and environmental justice. And I hope that I can report on our progress in the next research day. So with that, I would like to thank the ABC UTC for supporting this project, and thank you all for your attention and listening to my presentations. I'll take any questions or comments, and feel free to reach out to me using my email if you have further questions or comments. Thank you.
Thank you very much, Dr. EBRAHIMIAN. Definitely an interesting topic and something that I guess there's a lot of interest in adding the social equity to research, to construction, etc. So there are a couple of very interesting questions I would like to. I think we have 3 minutes time, but let's see if we can cover all. One interesting question, because you mentioned, I guess, reducing crime or so. It's asking what would be the relationship between construction duration and crime.
Well, it's really simple. You know, if you have a project that is located, you can think about, you know, a highly populated urban area or a very high crime rate area. There might be interruptions, and I have been working on these sort of projects in the past. You know, where some of the things may be stolen, you know, from the projects. There might be, you know, other interruptions from the adjacent community, and then this just simply means the increasing the construction time. So using ABC or accelerated methods could help with, you know, not facing these sort of, or basically reducing the chance of facing these sort of problems.
Okay, thank you.
Sure.
And the next one again, about the safety. You covered a lot on safety and accident-related issues. Are there any other available methods that is out there? Do they include or account for safety in terms of relation between duration and accident?
Well, I don't know the answer at this time, or we haven't, covered that yet. But the things that we know is, the current CTDOT method does have a criterion on work zone geometry. That's not related to the risk of crashes or the number of crashes in the area, in the work zone area. That's basically related to the duration of the projects and how complex the traffic flow diversion is in the project. For example, are you using, alternating one-way traffic lanes, or are you considering detours in the projects? So depending on these sort of characteristics, they consider, the different importances for using ABC. For example, if your project has a long duration and has a very complex traffic flow during the construction, so they give it a higher rate for using ABC. This is the current method. What you're adding here is actually the benefits of having less crashes during the construction, and this is something that we are using based on the recent project that was done. I think that was the Cycle 3 project by
Yes.
ABC UTC and also a
Yes.
PhD research. So there are, some clear findings from that project that we're going to incorporate into this method.
Exactly. That's I wanted to mention that you had it in your presentation too, that
Yes.
there is a completed project that covering somehow that option. Thank you very much again, Dr.
Sure.
Ibrahim. Appreciate your